I hope you can bear with me the next 30, 40 minutes. I know everyone is hungry, and we're already past 12 o'clock. So my topic will be augmented reality, so something completely different to what you've heard before. It's kind of the same idea as Andrew said before. That's something you would expect from a native app, but it is possible doing that in HTML5. We're not that advanced that you can do this fully in a web browser, in a mobile web browser, but I'll let you know why and how you can add augmented reality as a web developer. My name is Philipp Nagele. I'm coming from the company called Wikitude. We are based in Austria, in the very center of Austria. And my talk is split into kind of 5 parts. I'll tell you a little bit about the company. We're not as big as Microsoft or the FT, so bear with me when I explain you a little bit about our background. The evolution augmented reality has taken in the last couple of years, and then switching over why HTML5 or HTML and JavaScript is actually relevant for you or for augmented reality. And then talk a little bit about AR in the web browser. And although I'm not a developer, I'll give you a little demo on live coding and some other demos I've prepared. So who and what is Wikitude? Wikitude on one hand side is an app, very popular app, and on the other hand side, our company. Wikitude started 2008 on the very first Android phone, the T-Mobile G1, as the first augmented reality browser. We now call us augmented reality platform. We've been awarded 4 times the best AR browser in a row, so from 2009 to 2012, and also awarded the best AR tool or platform for our SDK. The installation base is about 13 million worldwide. We do have a couple of pre-installation deals with RIM and especially Sony. So you shouldn't be surprised if you see our app pre-installed on your phone. We've been hearing a lot about standards today. AR is an area which is totally out of standards so far. We've been driving that with the establishment of an AML standard called AML 2.0. It's not the W3C who's driving that, but it's the OGC because it's very related to geographic and latitude and location-based services. However, the OGC is the same consortium which has been standardizing KML. KML might sound familiar if you have been working with Google Earth or any other geo-based content. So that's the spot where we are standardizing our markup language on AR. That standard actually is pretty far. It is out for public review since December last year, and we expect to be a fully ready standard by March this year. The app itself runs on every major platform, Android, iOS, BlackBerry 7, BlackBerry 10, Windows Phone 7.5, 7.8, and 8. As I said, we do have a global usage. That is a screenshot of the 24-hour usage of the Wikitude app. There's nearly no place in Earth where Wikitude hasn't been called and launched. Obviously concentrating on North America, Europe, and also Southeast Asia. Who of you has experience with AR and augmented reality? Not necessarily on a developing perspective, but as a user perspective. I would say 30–40%, something like that. AR itself, the technical boring definition is it's the live view of the real world whose elements are augmented by computer-generated content. So like in this example, I think I don't need to explain the live image in the real world. But the camera image is capturing what's around me, the live view of the reality, and we are augmenting that by computer-generated information. So the definition is very generic. To give you a feeling what kind of typical use cases there are for augmented reality, I brought up a couple of examples. One of them is understand what you're actually looking at, so kind of a tourist guide, tourist scene. So this would be in the mountains, and you would like to know which peak is the one you're seeing 10 kilometers ahead. You would pull up Wikitude or any other AR browser and then start in what we call a world for peaks around you. And then it would identify the peak you're looking at. It's not doing that by image recognition, so we're not analyzing the scene itself, but just by analyzing the sensors of your phone, we can detect where you are, where you're looking at, and by that then superimposing the information to your screen. Very similar, it has to be in the mountains, can be in any city, exploring a city, and getting to know more information about sites, like here in Berlin, the Brandenburg Gate. Or if you're mixing social into that, can become interesting. I guess most of you know if you do some check-ins in Foursquare or you are geotagging your Facebook posts, you are putting a location to that post. And that can be evaluated as well, like we did in this example here, where you are following your friend's footprints. The likeliness of following a recommendation of a friend is much higher than following a recommendation, an anonymous recommendation of ABCDF on Quite or Yelp. So this is quite powerful. If you see your friends have been here in this city and they went this and there and this and there and that. Another field is gaming. Who of you have heard about Ingress? 2%, I would say. Ingress is an outdoor game by kind of Google, a subdivision by Google. It lets you plant virtual objects in your surrounding. So you have to be at the physical location to play that game, and you play that all over the city, basically all over the world. There are two fractions playing each other. That's kind of a perfect use case for an AR geo-enabled game. Think of Scavenger Hunt, the example here, Ice Age 4, that's a Netherlands and campaign in the Netherlands, where you're hunting the nuts throughout the Netherlands. The more nuts you get, the higher your score. Okay, probably rephrase that next time. This part here, that's obviously architecture. It's the Hadrian's Arch in Carnuntum, close to Vienna, an excavation site of the Romans. And the thing is, you probably notice it says Augmented Reality 1.0, because what you see here is not computer-generated information. Actually, it's a board, a transparent board mounted there on hinges, and if you're standing there in the right angle, you can see how that looked like 2,000 years ago. So the very same use case, visualizing something which is not there where they are, then actually looks like this. Different excavation site, a Roman gladiator school very close by. They didn't dig up all the stuff, but they looked for a way to make it visible what actually was there to the public. So they asked us whether we can help them. And we came up with the solution that they provided us with this 3D model of the Gladiator school. And we put that, or we georeferenced that geo-model. So if you go there, it's basically just an empty space. You don't see anything there. But if you go there, pull up the application, and watch that, you can actually wander around and go through the whole area and explore how this Roman gladiator school looked like 2,000 years ago. So kind of distilling that down, the use cases, it's really making the invisible visible and connecting the offline world with the online world. That's what the benefit of augmented reality is. I know a lot of you probably have tried an AR browser and they think, well, it's cool. Try it a second time. It's not that cool anymore. Why do I actually use that? But if you think of millions of use cases where you can apply that and make your use cases better, then it becomes apparent what AR is. Excuse me. Take this one. If we go a little bit back in time, augmented reality started or was first mentioned as a lot of technologies we're currently using in science fiction books of the 19th century. And it actually goes back to 1901, where this author, Frank Baum, mentioned a device which can detect things around you he called it an electrical fairy tale. So people back at that time were a lot about electricity and what that could do. But the idea of augmented reality and kind of enabling something around you goes back 120 times. And as so often, that moves on. Oh, here I am with Arnold Schwarzenegger. goes then all the way into Hollywood. So this still is from the movie Terminator, and that's already 30 years ago. So Hollywood was working on those concepts or putting them into mass-market movies already 30, 35 years ago. At about the same time, AR made its way into hardware systems, very expensive. This image is from a helicopter where the pilot is using a so-called head-up display, where information is injected into the head-up display, and the pilot gets vital flight data at the very same time as just looking out the window and observing the scene. So this is vital, but this system costs quite amount of money. So 4 years ago, the hype really started when the technology and the sensors for doing that were become available to smartphones and tablets. As I said, the very first phone was the Android T-Mobile G1, which included a GPS sensor, a compass, and an accelerometer. Nowadays, you will find a gyroscope in there, which is by far better suited to track the movement of the phone. Probably if you need to guess, out of those three sensors, GPS, accelerometer, gyroscope, and compass, which one do you think is the one least reliable in an outdoor scenario?
GPS.
That's kind of the common notion. Unfortunately, it is the compass. The compass is really our sensor, which is not reliable at all. It's very jittery and easily detractable. GPS is, in an outdoor scenario, is fairly reliable, but a compass is just a pain to work with. I probably will notice the three dots. The story continues, and as Jeff said, it doesn't stop with touch. It doesn't stop with smartphones. Especially, I don't think this one is the ideal scenario for experiencing your AR. We think AR glasses will make the scene this year. Don't think mass adoption, but I think we'll see some very, very interesting prototypes this year. That can be anything from Google Glasses. Obviously, they get most of the publicity. But Epson has already produced AR glasses which are out in the market. There are other companies like, what's their name? Wizar, which are also producing or have been producing AR glasses for the US Army for a couple of years. So we'll see quite a lot of things happening in this space during this year. We don't think it will be the silver bullet for all AR use cases, but think of sports where you don't actually can use your hands very well, but still want to get some information. Perfect use case. The guy at the very top, Matt Quen, an Australian guy, he did a do-it-yourself AR glass in his PhD thesis. What he's actually using at the very top is a standard Android phone, and he's projecting Wikitude data onto two semi-transparent glasses. It's kind of a fun project. I think he spent $40 on that. It might look a little bit weird, but it works as well. But what does that mean for you? It actually is kind of a separate output device, right? We're moving away from smartphones as an AR output device to a totally different one. And that might be a challenge for you and for the whole industry, right? Beside desktop and mobile, which we know how to deal with, there's another output device, which I call AR View. And I'm comparing the exact same content here for those three output devices or screens. On the desktop, feature-rich, a lot of controls, a lot of choices you can do. The mobile perspective already slimmed down and stripped down to the very necessity of the use case. If I want to change something, I probably need to go to a sub-menu, do 3, 4 more clicks. And if you think about AR, it's even more stripped down. Very narrowed down, just a section of the map is shown and the route. So no options at all, no other control. So it goes really down to the very bare use case you're actually using. And if you're comparing the information density on all those three screens, and by information density I mean how many information is presented to the user at the very same time. On the desktop, obviously, that is quite a lot. On the mobile, still acceptable. And on an AR view, it's very, very little at the very same time, just because you don't have a lot of space in front of your eyes. On the other hand, if you think about the context you're using your application in, that is very low in the desktop environment, right? You hardly know where the user is actually sitting. There are some APIs you can get from location, but you don't know what he's looking at or whether he's really there or not. That's somewhat better on a mobile phone. You can add context to your application. And that is even better on an AR view or AR view. And if we add those, my prediction will be that the relevance for the user is highest in the AR view. That's still to be proven, we'll see, but that's something I really expect. And how that all can look like is a demo video, again from Australia, from others. We probably don't have sound here, but 1 second.
Need to visualize what that property looks like. So from the floor plan, for instance, we could actually augment from the floor plan and put it out there in situ, on site.
As you can see from their concept video, the possibilities are endless. Augmented glasses could help you administer life-saving first aid in an emergency. They could make your online experience more intuitive, and maybe even help you play Fruit Ninja in the park.
The game space is...
So I don't believe in all of the use cases. I'm quite skeptical about the first aid and and putting on glasses, although I'm sitting in front of a computer in my office. But the gaming, actually, I think that could work. If you think what happens in a Kinect environment at home, people are already moving like this, and if you're watching from outside, you think they're crazy. But the one I really loved is the architecture use case, where where they're presenting the building plan on a actual print paper, and then projecting that into the real world. So there are two technologies merging. One of them is the image recognition part, where the application is recognizing the building plan as such, and then transferring that into, or georeferencing that, and putting that out there. That's fairly complex, but that's would be really cool. Well, the key question really is, if we're thinking about a new output device, as I said, you're probably familiar now with how to treat desktop, tablet, mobile. Now a new output device, how do you want to treat that? You definitely don't want to do that in a native application, right? You've invested that much time for HTML5 and responsive design and media queries and whatever. We also think the solution is actually HTML and JavaScript. So what we come up in last year is what we call the Architect Engine. And it is an AR render engine, or an AR engine, written in C++, available on iOS, Android, and BB10 at the moment, including a JavaScript API, which allows you to create AR applications using JavaScript and HTML, your standard web technologies, just by including a JavaScript API. It combines geo and image recognition features, and it packs quite a lot of convenience features for easy content creation. And how that works is we do have the real-time camera image at the very bottom as kind of the basic layer. On top of that, a 3D augmented reality view. And on top of that, a web view. And if you merge all those three layers together, that's what you actually see, or the users then see presenting on the screen. I guess most of you are familiar with a web view. That's kind of the standard mobile web view. You can develop anything. If it runs on a mobile phone, it will run here as well. The 3D augmented reality view, that's where the JavaScript API comes in. You're injecting all your data and application into that JavaScript API and controlling that AR view. A little bit more practical. I've had 3 layers or 3 levels. The real-time camera image, here of San Francisco, I think. Then on the top, this menu bar here, that is a regular web view, which includes jQuery mobile. Just a regular web view, nothing special. And the 3 points of interest, the hotels here in that respect, those are points of interest, which are controlled through the JavaScript API and will, or georeference points of interest, and they will hover depending on your position. So with that, you can actually create quite powerful interfaces, AR interfaces, as you like. For example, as I said, we added jQuery in that example. The menu slides in from the right and slides back. This list view, again, is just standard diffs and images, nothing special about that. Also, the filtering on the right-hand side, very regular mobile web stuff. a use case I was referring to, image and geo combined. Probably, if you're not familiar or not that deep familiar with with augmented reality, why actually talking about image recognition and geo, and why is that all the fuss about it? They're two very separate technologies, and companies until now took the route that either supporting geo-based AR, so sensor fusion-based AR, or image recognition AR. Both technologies have pros and cons. If you're in an outdoor environment, sensor-based AR is definitely better, just for looking at the far field and identifying what's around you. In the very near field, for example, detecting what's on the table, image recognition is the only way. So when I'm talking about combining that seamlessly, that's kind of not that usual at the moment. So in this example, we are augmenting the Your Shop logo that's printed on the flyer. We are superimposing a color version of the logo with 3 options for the user: find shops, get a deal, and open website. And if the user is clicking on get a deal, we're presenting him with the discount code on top of the image. And if the user is clicking or actually wants to know where I can redeem this code, you can present the user with a store finder just at the same very time. This should not be kind of a product description or product rundown, what the Architect Engine actually can do. I just want to give you an idea what AR interfaces can be made of and what a modern AR engine actually helps you producing. HTML drawables are just one form of visualizing your content. As I said, we do separate the web view and the AR view. With the HTML drawable, you also can create HTML content in the JavaScript API. So this label, which is hovering in the scene, is just a regular website, myhotel.html, where we're including all the necessary data for actually doing this one. Relative locations, beside absolute locations, right? You could define a point of interest by putting in latitude and longitude, but sometimes it's easier to work with, I want to present something 300 meters west to the current position of the user. You can do that on your own, but it's quite complicated. And if you want to do something like this one, a solar system, where you're putting the sun 400 meters away north to the current position of the user, and then let's circle the other planets or surrounding them through the sun, that might be a little bit tedious. With relative location, that's super easy. It's just defining an animation path around the sun. So this is not a 3D model which is animated. It's actually calculated on real time through the JavaScript API. And as I said, the compass is the one which is actually the worst sensor. You will notice that the sun is shifting sometimes. That's because the compass is recalibrating. That would not be possible with animations. The JavaScript API supports sprite animations, very similar to CSS3, but also 3D transformations and animation groups for easier handling. Comes with a ready-made radar component that helps users to find content which is around them. It's fully customizable, the same code basically for both of them, more fancy version, a very basic version. You just apply a skin to the radar and it will work out of the box. As I said, image recognition is part of such an engine as well. In our case, that's JavaScript code on the right-hand side. You're defining a tracker. A tracker is the reference image you want to be able to track. You're applying a new image to that as well, the overlay. The overlay in this example is this label here, architect, and the arrows, and also the pencils. And then you'll basically push that to the JavaScript API, and every time the image is detected, it will show this image on top of that. And we're also going to support 3D models in the very near future. You can import 3D models from Maya, Blender, basically any popular 3D modeling tool, and put that out then as a drawable or as a visual representation. As I said, the question now is, if it's already based on HTML, HTML5, and JavaScript, can that run in a mobile web browser? And the answer is yes, and the answer is no. No, because we're not there yet. It would in terms of standardization, HTML5 would be enough for us to create an AR scene. We do need the Stream API for capturing the real-time camera image. We need the geolocation API, obviously, for getting the actual position of the user. And we need the device orientation API for being able to tell where the user is looking at. We've been doing a proof of concept with Opera on that. And this is a screenshot from a standard web page on the Opera mobile browser, which includes a window. We call it AR window, which is running the live image of the camera. And if you're turning and twisting, you will see the content changing according to your position. All right. Some live demos on what that looks like. And bear with me. The setup is not the easiest one. That's what I thought. Hold on a second. Okay. Ta-da! Excellent. So, say hello to yourself. I brought a couple of use cases and demos I'd like to show you. The first one is what we call the city map. So as a target, I do have a regular print version of the New York City map. They're trying to add some details with a 3D view of all the different buildings. But we think New York is much more exciting if you're actually experiencing how New York City looks like. It's loading the 3D model now of New York City. That's quite complex, so bear with me a minute. Then that should work and run. While we're loading that, another use case is advertising, obviously. Advertisers love us because you can annotate anything. And I do have an advertisement of, here we go. Oh, we don't. Give me one more second. An advertisement of a beverage company, very well known throughout the globe. And you could not guess from just seeing it that it's a Coke advertisement. But if we add augmented reality to it, should be able to recognize it. Yeah, here we go. So we are augmenting that with sound, images, and snow animations. Probably a little bit more practical example. What I do have here is a movie billboard of the movie 7. And, it's kind of boring just in print. If I want to know more about the movie, just scanning the image. And it presents me the trailer, the live IMDb rating, and also some critics of the movie. And as you can hear, it's starting to play back an audio file of the movie.
Applies sometimes. Most times.
Right. Let's switch back to the city map. Oops.
Before we go.
You're retired.
I guess I have to show you the city map later. But for my very last use case, I need the help of the audience. Someone of you has a 10 euro or 20 euro note Actually, you can come up and I'm not going to steal it or borrow it. Any one of you, 10 euros, not pounds. Andrew. As I said, you can use augmented reality to make things. You can wait here if you want. Yeah, exactly. As I said, augmented reality can help you make products more self-explanatory. You can help making the invisible visible, and it's kind of not really stable here. Sorry for that. What we did is we're augmenting standard Euro notes, right? That's not kind of prepared or something like that. That's an application you can use in the standard Wikitude application. It's called Scan Your Money. And it helps to detect the security features of a banknote. We had that before, right? So a short explanation what it does. So here we go. Of course, that's bad. Here you go. It detected the euro note, and it's showing the security features of the 10 euro note. And then by clicking onto that, it would explain me what it does. You also saw a real-time currency converter. It will tell me at the very bottom the 10 euros are 13 US dollars at the moment, 12 Swiss francs, and so on. And you couldn't do that. Of course, you can do that in a native environment as well, but it's kind of cumbersome. All the visualization part, all the image recognition part is done on base of HTML and JavaScript. So there is no native development for this particular use case necessary. So you can do that. At the moment, it can run or is rendered only in the Wikitude web browser or in the SDK, which you can include in any of your apps. But with AML 2.0 coming out this year, we see that also moving to the web browser, to the standard web browser. All right, frozen. Thanks, Andrew. 10 years back. And as I promised, I'll give you a short look at the code necessary for the Coke advertisement. And it basically consists only of two files. One is the index HTML, a very simple, very basic HTML file, which is loading a JavaScript file. The key parts here are the inclusion of the architect JavaScript library. You can see, or you can tell by the architect denominator that it's not, you can't do that in a standard web browser. But the Wikitude web browser and the SDK will detect that and load the JavaScript library. And then the other part is loading the logic file. And in the logic file, I'll scroll through that, the entire list. That's it. That's all the code you need for the Coke showcase and also the 7 the movie billboard. Basically what we do, we're preparing all the media we'll need, the MP3s, the images, and then attaching that to trackables. That's all you need. And as I said, standard HTML file. We do have a div here at the very bottom with a CSS class attached to it. And if I'm changing that and run that in a browser, calling the same URL again, you will notice that it didn't change. I must admit the internet connection is a little bit shaky. That shouldn't be an excuse at all, but the setup is very peculiar with the Wi-Fi here. So obviously the div at the very bottom, at the very top should change. Sorry for that. But as I wrote, enjoy your meal. If you have questions, we'll be here for the next 2 hours, or we can take them now. Petro, how do you like to do that?
Yeah, thank you. I'm sorry about the Wi-Fi, so it's sort of took your demos down, but impressive stuff anyhow. We can have a couple of questions and then head to lunch and be back at 2. So a word of warning right now about lunch that please be patient. So the space is sort of limited, so there will be some queues. So if we can kind of gradually, in a nice and polite fashion, go pick up food, that's going to be good. But a couple of questions, please go ahead, and we're going to stick around here for some minutes. And if you want to postpone lunch a bit, maybe Philipp can stay around to answer even more.
Questions before lunch is usually low.
I can just give a comment, at least that last one wasn't HTML5. It was HTML1.
Yeah. We need to change the demos.
All right, thanks for your attention, and as I said, I'm just going to go on.
Thank you.